Hi, everyone. My name is Mara Hosko. I am a ML specialist at AWS, and I'm focused on SageMaker Studio, SageMaker Notebooks, as well as RStudio and SageMaker, which is what we'll talk about today.
Hi, everyone. I'm Farooq Saber. I'm an AI ML specialist solutions architect at AWS.
So today we're going to focus on RStudio and SageMaker, which provides you with the familiar RStudio IDE utilizing on-demand cloud compute resources. So you can launch RStudio Workbench with a single click from Amazon SageMaker. So your R developers can dial up compute with the same interface, reducing interruptions to work and improving productivity. During this workshop, you'll learn to use Amazon RStudio on Amazon SageMaker. So for the learning objectives for this workshop, first, you're going to learn how multilingual developers can switch between the RStudio and SageMaker Studio notebooks for both R and Python workloads. You're going to understand how developer work, including code, datasets, repositories, and other artifacts, are automatically synchronized between the two environments. And thirdly, you're going to see how to lift and shift the RStudio environments that you have to Amazon SageMaker. So now we're going to deep dive into RStudio on Amazon SageMaker. So right now, if you have your RStudio Workbench and IDE, it can be a little bit challenging managing it. So you have to kind of set up and maintain the infrastructure and user accounts while also managing your license. And then once your team is on RStudio, they'll want to collaborate with other R developers and Python developers, database and data lake managers and business owners. There's a lot of different stakeholders involved for kind of that seamless interaction. And then thirdly, it can kind of be a time-consuming effort that really gets simplified by RStudio on SageMaker. So RStudio on SageMaker is fully managed, which means it uses Amazon SageMaker to build, maintain, scale, and secure RStudio deployments. So there's no need to actively manage clusters and update versions. It's all fully managed and enterprise ready. So you can choose a variety of different instances available at AWS that could be compute optimized, memory optimized, and GPU instances. And with each session, you choose which instance type is best for you and your workloads. So you can kind of easily kind of scale and spin up and spin down based on your needs. Secondly, it's kind of a quick lift and shift to your current RStudio license. So there's no need to kind of do additional work with your license or any cost. It's very easy to migrate your current RStudio license to Amazon SageMaker with a few additional steps. It's also familiar. So the same RStudio Workbench that you currently use now is the exact same that you'll see on RStudio on SageMaker. So there's no need to kind of reintroduce our developers with any new interfaces. It's all the familiar interface that you have now. It's also very scalable, as we mentioned. So you can kind of scale up and scale down the compute as necessary. So you can run large data processing and statistical analysis. And those instances can range from 4 gigabytes to 768 gigabytes of RAM. And lastly, it's really unifying of your team. So if you have R developers or Python developers, you can kind of really bring them together on Amazon SageMaker since it uses the same kind of shared common services like a EFS mount, an S3 and code commit. So there's kind of a lot of sharing that you can do across those teams. So as mentioned, the same familiar IDE of RStudio is now on SageMaker. So you can use the same integrated development environment, and it's fully managed on RStudio. Fully managed on SageMaker. And so it's pre-configured with R packages, and it publishes using RStudio Connect. And so you can publish using RStudio Connect. It includes a console and syntax highlighting editor that supports direct code extension, as well as tools for plotting history and debugging and workspace management. It's kind of that very familiar IDE, just fully managed on SageMaker. And so, like we mentioned before, you can choose a variety of different instances. And so that's up to like 40, 50 plus instances that are available to you. As we mentioned, GPU instances, memory optimized, compute optimized, all available for your data scientists to use. And so each each user on RStudio has access to the managed domain in Amazon SageMaker. And so each user kind of logs in and has their own domain, which then shares kind of a universal home directory. You can easily scale the workloads. You can run sessions on Amazon SageMaker instances without having to manage a compute cluster. It's all fully managed. And as we mentioned before, with each new session, you can choose which instance type is best for your workload. And with that shared file system, your data will not be lost as you start new sessions. And just kind of to reiterate, there's security at scale. So you can authenticate users through AWS IAM and SSO. You can configure internet access through VPC and set up data encryption in transit and at rest. You also have access to a lot of the other AWS SageMaker components. So you can access SageMaker hosting. You can create an endpoint with RStudio on SageMaker, which allows for scalable endpoints, and you can use auto scaling, or you can have an API call to train your models using SageMaker training. You can take advantages of features like distributed training as well on SageMaker. So there's really kind of a lot of seamless integration with the AWS SageMaker ecosystem. You can also bring your own license. So it's very easy to lift and shift your RStudio environment that you currently have to Amazon SageMaker. Again, you can easily kind of shift your license to Amazon SageMaker. There's no need for extra costs. It's the same terms that you have with RStudio. So it's kind of very seamless and easy. You can also manage your license through AWS License Manager. So your IT managers have an easy way to manage, discover, and report their RStudio licenses. You can also configure environment and users from Amazon SageMaker. So SageMaker automatically identifies licenses from AWS License Manager. So the Amazon SageMaker Studio user profiles can be authorized to access RStudio. And that can be the total number of our authorized users that are tied to your RStudio license. And lastly, you can bring your own RS image with custom libraries. So you have your own custom libraries. RStudio on SageMaker allows you to kind of build your own custom images. And so this helps you standardize and simplify. This can be useful if you have containerized environments on RStudio Workbench that you want to bring over to RStudio on SageMaker. From a security perspective, the RStudio has a central administration. So you can set up user identities, authorization, networking, and storage. It's secure. So enterprise features coming out of the box include disabling public internet access, private link support, root access controlled, pre-signed URLs, and it's secure with encryption in transit and at rest. And this month, the default version of RStudio that is deployed when a new domain is created will support encryption between the RStudio Workbench and all our sessions apps, which provides full end-to-end encryption. And lastly, from a compliance perspective, it's currently compliant with HIPAA and SOC 1 and SOC 2, and there's others in the works for compliance. So there's really kind of this secure ecosystem that you have within RStudio and SageMaker, as well as the SageMaker and AWS ecosystem as a whole. And lastly, you can really easily toggle between RStudio and SageMaker. So since they're using the same underlying home directory, that data is the same. So you can access the same file mount, the EFS that's kind of shared between Studio and RStudio and SageMaker, and the files can easily be accessed via both. And so you can use Studio features to visualize your pipelines or track your experiments that you create in RStudio, and then you can visualize it in Studio. So you can see here in these screenshots, on the left, we have the familiar RStudio IDE, and that's kind of the code for building a pipeline. And you can kind of see that in the RStudio. And then on the flip side, you can visualize that directly within Studio, the Studio SageMaker IDE as well. And so you kind of easily switch. And so if you have R developers and Python developers are communicating, they can all access the same data and kind of utilize some of those shared features as well. So getting started on RStudio on SageMaker, we have tutorials, we have workshops, which we're going to go through very soon. You can look at cloud formation templates as well, and example code. If you want to play around, you can get your onboard through the SageMaker console. It's very easy, just one click, especially if you have your own license that you have with RStudio. And you can also utilize AWS ProServe and partners to really help you kind of leverage RStudio and SageMaker as well as SageMaker features. And so without further ado, I'll pass over to Farouk to go over the workshop.
Hi, everyone. So let's go through our labs today. So today we are going to cover 2 labs in RStudio on SageMaker. And we are going to provide you the URLs to log into those labs and run them into AWS Sandbox and run RStudio for SageMaker from there. Okay, so to get started on these labs, you need to first log into our sandbox here at this dashboard.eventengine.run/login. We will provide you this login, and over here, you need to put in this event hash that we are going to provide you, and then accept terms and login. And once you get over here, let's do an email one-time password. This is going to send you a password to your email address that you are going to use to log into this sandbox. And this sandbox is provided by AWS, where you can run your SageMaker, SageMaker Studio, and RStudio, and other AWS tools in there, and do experimentation and work there. And this sandbox is going to stay active for another 24 hours. So I recommend that you follow along, and then after this session, you log in there and carry on with the two labs that we show demo here in today's workshop. So let's type our email and have the passcode sent to our email. It is going to take a couple of minutes at maximum. And once you have the passcode, just enter it in here so we can log into our sandbox. Okay, so once we receive this password, we enter it here, and then we press sign in. And it is going to take us to this AWS console, team dashboard here, where it is going to show you our sandbox. And over here, click on this AWS console, and at the console, let's click on this open console here. Okay, so in this console, let's click on Amazon SageMaker, because that is where we are going to run RStudio and do our experimentation. So clicking on Amazon SageMaker brings us to the SageMaker console here, where we are going to click on Control Panel. Okay, so in this control panel here, let's click on this Launch app, where you can see the different tools in here in SageMaker for carrying out their experimentation. These are a few of the tools. We have several other tools in the SageMaker, Amazon SageMaker, which are listed on the left here. So in this Launch app, let's click on RStudio. So we are going to run our labs on RStudio, and then we are also going to go in SageMaker Studio to see that the pipelines that we build in the final lab, how they show up there in SageMaker Studio. So clicking on RStudio is going to open RStudio Workbench for us. And in RStudio Workbench, you need to start a new session. So I started a session yesterday, which I'm going to use for the labs here. But to show it here, let's start a new session here. So in the new session, let's give it a session name. Editor, we use RStudio. And you can also select the type of compute instance that you want to run your RStudio session on. So there are various choices provided here. Some of them have several CPUs, some of them have large memory, and some of them have GPUs as well. So depending on what you want to do, you can pick and choose different instances. Of course, the price is different for the different instances here. A general good practice is to use the instance, the smallest one that helps with your exploratory analysis in the workbook, in the notebooks, in your RStudio session, and then run processing or training jobs on larger compute or GPU instances from the code in there. So that doing that, start separate instances where you run where your code is being run. They're fully managed by Amazon, and once your code is finished running, you get the results back, and and those instances are shut down, so you don't pay anything extra for it. From the image, we have this R session base here, but as Mayor mentioned, you can bring in your own R image with your own custom libraries as well. So we're going to start this session, and it is being started here. So while it's being running, let's go to the session that I started yesterday and experiment with our labs in there. Okay. So clicking on that session brings us to this RStudio window here that we are all familiar with. So in here, we are going to clone a repository. Okay, so these are the labs that we are going to run today, and I have these open here already, but let's go to this terminal over here, and let's clone our Git repository. So this is the Git repository that we are going to run our workshop today. Okay, so I have this repository already created here. So for the demo purpose, let me show you how to clone it. Let's create a new folder, workshop here, and in this, let's go to this workshop folder here, and now git clone our repository here. So this repository is being created in this in this folder here, and we can go in there and look at the different labs that are in there. Okay, so I ran these labs already yesterday, so I'm going to go through these labs today, talk about it, what these labs do in here, because they take well over 1 hour to complete. So I'm going to, I already ran it yesterday, and I'm going to go through them right now with you. So let's click on, go to this 01_SageMaker folder and click on this R markdown file here. This is the file that is open here. So in this R markdown file, what we are going to do is we are going to run, we have a synthetic data set for a telco use case, where we are going to model it as a classification problem and predict whether, given certain features and variables, we are going to predict whether a customer is going to churn from the company or not. Okay. So in this first cell here, we are going to import some libraries here and packages here. We see that we are going to import this reticulate library, which is going to help us run some of the Python code in here in our studio, such as the SageMaker Python SDK that we are going to need to run an XGBoost model, which is part of the SageMaker Python SDK algorithms. Okay, so in this next cell here, we are going to basically importing the SageMaker Python SDK here and specifying some of the variables, environment variables, such as the session and the S3 bucket, where our data is going to sit for model training and our execution role. Okay, now we are going to download this churn data set and are going to display. So this is the data set that we're going to use. It is being displayed here in this markdown file, and we can also click on this over here in this window to the right to look at the table in RStudio here. You can see that it has several variables. This final variable churn question mark is our target variable, where we are going to predict whether the customer is going to churn, it's true or false, whether the customer is going to churn or not from the company. And we can see that there are several numerical variables. There are some binary variables as well, like international plan and voicemail plan, and there are several categorical variables such as state here. Okay. So going back to the markdown file, in the next cell, we are going to do some basic operations here. We are going to use dplyr library as well, which is open source, that you can bring it in RStudio on SageMaker and use that, as well as we are going to use pipe operation to do some basic manipulation here, such as changing the variable names, converting our binary variables to dummy variables, one-hot encoding them, converting our categorical variables such as state to dummy variables by one-hot encoding them, and then running our plotting some plots using ggplot, and then running our XGBoost model, which is part of SageMaker. Okay, so in this next cell here, we are changing some variable names, and then using ggplot to plot this histogram here for our target variable customer churn as a function of international plan, whether the customer has international calling plan or not. So on the left is the case where our customer did not churn, and on the right with the customer churn, and we can see that distributions are quite identical. So this variable probably does not have much impact on our target variable churn. So now let's plot customer churn, two more histograms as a function of how many customer service calls did each customer make. So plotting this distribution, we can see this is the histogram when the customer did not churn, and this is the histogram when the customer churned. And we can see that in the tail on the higher end of this distribution, where we have more customer calls for customer when the customer is going to churn. So this variable probably has some impact on customer being churning from the company, because it shows that those customers which are making more customer service calls probably have a higher probability of churning from the company. Okay, executing this next cell in this file. Now this next cell is carrying out some pre-processing steps, such as converting some of the binary variables to dummy variables, one hot encoding them. Okay, so first of all, it is converting our churn variable from true or false to 0 or 1, and similarly, it is also converting such as international plan, which is also a binary variable, as well as voicemail plan. So these are converted to 0 and 1, and then also the state variable, which is also a categorical variable, is also converted to zeros and ones into dummy variables in our data set. So we click on this churn table again, and we can see that in our pre-processing, we also moved our churn column to the front of the table at the beginning of the table, because the built-in XGBoost algorithm in SageMaker, that's what it requires. It requires your target variable to be the first column in the table. And then we have all these numerical variables followed by these two variables, international plan and voicemail plan, which were also binary variables with yes or no in there, and now we have converted them to 0 or 1. Similarly, the state column in our table has been converted using dummy variables to these multiple columns here, one column for each state with 0 or 1 value in there. So these were the some of the pre-processing steps that we carried out in this lab here. Now moving on, we are going to divide our data set, the churn table, into training, validation, and test sets. For training the model using the training and validation set, and then finally getting a benchmark on our data set, or predicting using the test set. So here we are converting them and writing them as CSV files in here. Okay, and in the next cell here, we are going to upload these data sets into our S3 bucket, because we are going to use S3 bucket in here to train our models. Our model XGBoost is going to read the data from the S3 bucket and train the algorithm or the model from there. Now we are specifying the training and validation channels for our model. And in the next cell here, we are using the SageMaker XGBoost container for running our model. Now in the next set, we are configuring our estimator, and this estimator is our consists of our XGBoost algorithm, as well as we are specifying the role that we are going to run, use to run this model, as well as the type of instance that we are going to use, the compute instance, and the number of instances that we are going to use, and our S3 output path, of course. So here we can specify different instances types. So this instance is going to start when we call the fit method in our estimator, which we are going to do in the next cell, and calling that fit method is going to start this instance. The training job is going to run on this instance. And once the job is finished, we are going to get the results back in S3 bucket, and this compute instance is going to shut down. So we are only paying for using the compute for the amount of time that our training job is running, and not paying anything extra. And we can that's how we can also pick compute instances with several more CPUs, with larger memory, or with GPUs as well. And if our model or algorithms supports running on in a distributed fashion on multiple instances, then we can also increase this instance count here to run our model on multiple instances to if you want to run if you want to get the results faster, or if to run it on or if you have a very large data set and we want to run it on multiple instances too. Okay, so in the next cell, we are going to start this training job. Now, this is going to take a few minutes. So I ran it yesterday, and I'm going to show you the results here. It finished running, and you see that when it started running, the validation error is 0.102. This is the error on our validation set. And as the algorithm proceeds and multiple iterations are run, this validation error is going down. So you can see that from 0.1, it has come down to 0.04 here. And as we keep going down here, finally the model training terminates when our error is 0.045. It took 93 seconds for this model to run on this particular instance. So once this model has been run, we are going to deploy it as a real-time endpoint. So this endpoint is a persistent endpoint, and we can call it from SageMaker here as an API call, and we can send data to it to do predictions on this model. And it's a real-time endpoint, so it is going to run all the time until we shut it down. So we can use it in our applications to send data to this endpoint, get results, and do predictions and get results. So here we need to specify the type of instance here. We are specifying this particular instance here, and we are also telling it which instance type, how many instances we want to deploy our model on. So here we are telling that let's deploy the model on only one instance. However, in SageMaker, we can also configure an auto-scaling policy where as our traffic increases, requests for prediction increase, the SageMaker automatically scales up, spins up new instances, deploy the model there, and once the traffic goes down, the number of requests they go down, then it starts shutting down those instances automatically up to a minimum number of instances that we specify. So we can specify a minimum and maximum instance count in our auto scaling policy, so that SageMaker can automatically manage our scaling up and scaling down of our of compute instances for our endpoint. So here we deploy our endpoint, and in the next cell, we are going to send some data set to this endpoint for prediction from our test data that we had set aside for testing in here. Okay. So we send this data to the endpoint. We get this probability of a customer churning or not, and we append it in our table as the first column here. So this is this churn is the truth, the actual variable output, target variable output, and this predicted churn is what our model has as predicted. In the next cell, we use half as the probability threshold to predict whether the customer is going to churn or not. And we show the confusion matrix over here. Okay, so here it shows the confusion matrix as well as some additional parameters some additional metrics that we are interested in when we are carrying out our data science work, such as sensitivity, specificity, and some other values. We can also plot the receiver operating characteristic curve here, which we're plotting using the ggplot library, and we show this ROC curve for sensitivity and specificity here in this plot in here. And finally, once we are done experimenting, if we are not going to use this endpoint for production and we are finished with our experimentation here, then it's a good idea to delete this endpoint because it continues to incur cost while this endpoint is running. However, this is a sandbox environment which is going to shut down tomorrow, so you don't need to worry about this. These resources are going to be automatically deleted. Okay, so this was all for our lab number 1. Now let's move on to our second lab, which in our case is going to be this third lab in this workshop that we are going to do. So you're also welcome to try this second advanced SageMaker lab here that shows some additional features of RStudio in this lab. However, we are going to work on this third lab here in our next demo here. All right, so let's get on with our next lab. For the next lab, we are going to build a pipeline, end-to-end pipeline in RStudio on SageMaker. So this is the lab that we are going to do, the 01 pipeline.markdown file. So what this lab is going to do is we are going to carry out some pre-processing steps. We are going to carry out train a custom model. We are going to evaluate the model, do some pre-processing, some post-processing. We are going to check whether the performance is better than certain threshold, and based on that condition, the model is going to be registered with our Amazon ECR, and then deployed as a serverless endpoint. So the pre-processing, training, evaluation, conditional evaluation, all these steps, and then pushing to model registry, we are going to build as part of a MLOps pipeline in RStudio. And then finally, in the notebook, we are going to also deploy the model to a serverless endpoint. So in this lab, we are going to use a custom model and build a Docker container, include all the packages in there that are needed, and then use that Docker container to train our models. And the model that we are going to use, the custom model, is basically the LM model in R, because this is in this lab we are going to carry out or solve a regression problem on a balloon data set, which is also available from the UC Irvine's website, where we are going. It's a regression problem where we are going to predict what is the age of Abalone depending on the number of rings. So we are predicting the number of rings on Abalone basically. Okay, going back to our lab here, just like the previous lab. Let me actually clear this first. Okay, so we are going to, just like previous lab, we are going to import our libraries here, libraries and packages like dplyr, reticulate. We are configuring our SageMaker Python SDK, and also some other libraries, AWS SDK for Python as well, and our session, our S3 bucket, and our role. Now, in the next cell here, we are getting the Abalone data set, and we are going to look at this data set where we have different numerical variables. Our target variable here is an integer that we are going to predict using a linear regression model, and we also have this sex, which can be a male, female, or an infant, I for infant. here for Avalon. Okay. Going back to the lab here. So the next cell we are converting our one of the categorical variable here, sex, which is female, male, or infant, into using one-hot encoding. Okay, so this is our new data set here. Let's see. And we're doing it for only the test set here, because this is what we are going to use later on to predict. For the training and validation set, we are going to do it as part of our processing script in the pipeline. Okay. So running this lab here require us to build two containers, which we are going to build in this Docker setup file. So we run these three cells here. So in the second cell here, we are building a processing Docker container, and in the final cell here, we are building a container for training and deploying our model in RStudio on SageMaker. So this processing container, the pre-processing container, the files for that are in this folder here, the pre-processing folder here. But let's look at our Docker container first. So this Docker file processing is the file for building the pre-processing container. We click on this, we see that it is importing some packages here, such as the tidyverse and this JSON. And the second container is this train and deploy container, which is also importing some additional packages here, as well as it is specifying this entrypoint.r file for our training container. Okay, and this is the entrypoint container file, which is specifying some of the parameters that we pass it, like the S3 bucket and the code for example, code directory, for example, and also the file for deploying our model as a serverless endpoint. Now going back and looking at the pre-processing file here. So the pre-processing file here is doing the same thing that we did for the test set. So for the data set, it is converting our sex variable, which is a categorical variable, into 0 or 1s using one-hot encoding. And it is also dividing our data set for splitting our data set for training and validation. Okay, and it is writing it into the CSV files in this container, so that they can be used for training. Okay. Going into this training folder here and looking at the file for training our model, we see that this file is reading our CSV files which we created, and then using this LM model here, linear regression model for training a linear regression model for predicting the number of rings in our data set. And we're also telling us we are also using root mean squared error as our metric to evaluate to train and evaluate our model here. In the deploy file here, we are actually deploying. We are specifying a function for carrying out inference on our data set, on our test data that we are going to pass to the model for predicting, and it's using Plumber as to help us in carrying out this task. So now let's move on to our lab in actually building the pipeline here. Okay, so this lab is going to take well over 30 minutes to finish. So I ran this one as well yesterday, and now I'm going to show you the results of running it. Okay, so in the next cell we are running this pipeline.r file. This file is here in our lab3 folder. We are going to click on it and see what this file does. So this R file, what this is doing is it is carrying out, it is building the SageMaker pipeline for us for carrying out all this processing, training, post-processing, evaluation, and model registration steps here. Okay, so we are specifying in this code line here the Docker container that we created in our Docker in our Docker setup markdown file here for SageMaker processing. So this is the container that we are calling here. We are specifying the different data sets that we have for processing, the training, validation, and test sets. And we are creating a processing step here in our SageMaker pipeline. And this processing step is going to take that pre-processing file here as the input, which is going to do one hot encoding on the data set on that sex variable. It also takes as input this script processor that we have created here, where we specify the number of instances, compute instances on which this processing job is going to run, as well as the number of instances. So just like training in the previous lab here, we are specifying let's run this processing job on the number of instances that we specify here, which in this case is 1, and the type of instances. So these instances are also fully managed by SageMaker. They are going to run. They are going to start. The code is going to run. We're going to get the results back, and these instances are going to shut down. So we will only pay for the amount of time that our processing job is running, and not for anything extra on that. Okay, so we create this step here, and in the next step, now we are going to use the container that we build for training and deployment. And here we are using this estimator function. Again, we are specifying this train.r file for model training, as well as the number of instances and type of instances on which this training job is going to run. In addition, we are also specifying the metric that we are using for training the model, which is the root mean square error on our validation set, with which that's going to be used for help in our training our LM model. Now we are creating the training step here, just like the processing step, passing it this estimator that we have, which we have defined here, and also the S3 path, and that our data is actually in text or CSV format. Okay. Now we have a post-processing step in here as well that we are specifying, and in this again we are telling it the type of instance here and the number of instances that we are going to use. Okay. And again, we are going to use the container that we built for SageMaker processing. And here we are going to use this evaluation.r file to actually that we looked at it to actually evaluate our model as the post-processing step, which is in this evaluation.r file. Okay, so this file is actually computing this root mean squared error here, and then it is giving us the output of this root mean squared error, which we are going to evaluate in a conditional step in our pipeline with some values to decide whether our model is performing well or not. Okay. Going back to this pipeline, .r file. Now we are using a register model API call here for actually registering our model and specifying the type of instances that we can pick from for running our model. So here again, we are going to use a serverless endpoint in our notebook. In serverless endpoint, it's going to look at these instances and pick one of them, decide on its own which instance it should use for deploying the model, and it scales up and down automatically as well. And we don't need to specify the number of minimum or maximum instances for serverless endpoints. And serverless endpoints also are not persistent, so you are not incurring the cost while the endpoint is running. Only you are incurring cost for when you get inference requests for prediction, for example. Okay, so now here we are defining a condition less than or equal to. We are using the root mean squared error that we get from post-processing step here and comparing it with a value of 6. And this step is telling us that our model is good if the root mean squared error is less than or equal to 6 here. And if that is satisfied, then in this we are using this condition step in SageMaker pipelines here, where if our less than or equal to condition is satisfied, then we register our model. Otherwise, we don't. Okay. And now we are adding all these steps to our pipeline here, which is step process, the processing step, pre-processing step, the training step, evaluation step, as well as the condition step. And then we are returning the pipeline back to from where it is called, which in this case is this markdown file. So here in this markdown file, we are actually we are creating this pipeline and starting the execution of this pipeline. We are in the next cell. We are waiting here and describing the different parameters of our pipeline here. We can see the once it is finished running, then we can actually go on and carry out. We can deploy it as the model as a serverless endpoint or real-time endpoint if you want to, or asynchronous endpoint also if you want to. But in this case, in the next cells, we are actually if the model is approved, then we are here we are basically getting the approved model, the best model out of the different models, the latest one, and then we are actually applying it as a serverless endpoint here. Okay. So in deploying the serverless endpoint, we are also telling it the memory size, and next we are deploying this endpoint here. And finally, in this cell, we are calling the predictor function to predict on three rows, 3 data points in our test data set, and getting the value out for using the model that we have just trained in our pipeline. Okay. Okay, so this was the creation and execution of our pipeline. So this SageMaker RStudio and SageMaker Studio, we can toggle back and forth if the folders and files that we have created in RStudio here, they show up in SageMaker Studio in the same region as well for our account. And what we have created in SageMaker Studio, they also show up in RStudio and SageMaker here. So let's go and go back to our AWS console. Okay, if it shows you this expired a link here, go back and click on and open this console again from the Event Engine dashboard. And then let's go to SageMaker. So we are back in SageMaker console here. Click on Control Panel, go back to this Launch app here. And this time we are going to start SageMaker Studio here. Okay, so this is SageMaker Studio here. In SageMaker Studio here, when we get into this console, we can see the different folders that we created in RStudio. So this is the folders that we created there. All the files are in here. And the pipeline that we have created in RStudio is also going to show up in SageMaker Studio here. So we click on this yellow triangle on the left here. And this from this drop-down list here, let's select pipelines. Clicking on this pipelines will show us the different pipelines that we have run. So I created and ran this pipeline around 20 hours ago, so it's showing up. We double click on this, and it is going to open this screen here, which shows the different executions of our pipeline. So we click on this pipeline here. This is the actually, let me go back and look at the graph here. So this is the graph that our when we created those steps, it automatically created this directed acyclic graph. And in this DAG, we have these different steps in this order, starting from processing step, training step, evaluation, conditional step, comparing the model with that 6.0 value, and then registering the model here. Okay, we can also look at different settings for our graph, our pipeline here. And in the executions tab here, we can look at the different executions that we did for this pipeline. We can also start a manual execution by clicking this create execution as well. But let's go into this this pipeline run that we just did in RStudio. So here the green steps mean that these steps have been already finished running. If it shows up as gray or other color, it means that these steps are not run yet, and those which are finished running show up as green. So we can click on these tabs, look at the inputs and several other parameters for this tab, and if there is any output, we can look at it. In this case, it is telling us where the output artifacts are sitting for this processing job, the different logs where they are, and what was the elapsed time, for example, and start and end time for this processing job. Now let's go to this training tab, and similarly, it shows us different parameters like the number of instances, type of instances. We can click on this output tab here and look at the root mean squared error, which was our metric for validation set over here. So we can do this for all the steps here in our pipeline. Remember that this pipeline was created in RStudio, and now we are in SageMaker Studio to actually visualize this pipeline, or we can also run it again using that manual, this create execution button as well. Okay. All right, so this is what we have for you today for our workshop session. Remember, we carried out 2 labs here. The first one, in the first one, we trained a classification model using built-in XGBoost algorithm in RStudio on SageMaker, and in the second lab here, which is lab number 3, we built our own custom containers, and we use the LM model as the model in there. You can bring in your own custom model there as well. And we did a processing step, a training step, an evaluation step, comparing with a pre-specified threshold, and then registering the model step. And all these steps are included in SageMaker pipeline that we built. And finally, we deploy the model as serverless endpoint in this lab in RStudio. And then we went into SageMaker Studio and look at the directed acyclic graph that was created by our code in RStudio in here. So thank you very much for joining us. This is all we had for today. And now we are going now you can ask, now it's open for question and answers, and please feel free to work on these labs. Remember that the sandbox is going to run for another 24 hours. Thank you.